moving ahead to the second step, which is understanding the problem. In understanding the problem, you must understand the knowledge base knowledge base of the person or the machine for whom you are designing the solution. For example, if there is a person who has asked you a way from Sinhgad College to Swargate, and the person is not understanding Marathi, then you cannot explain the map or the address in Marathi. It has to be done in a language which the person understands. So while understanding the problem also, we should understand for whom you are solving the problem and what that person has knowledge base about. So here for a person, you should know what the person knows, and on behalf of that or on top of it, you need to explain the problem. Instruction set will differ as per the knowledge base. This is obvious that as the knowledge base differs, instruction sets will differ. And for a computer, the knowledge base is something different. The computer basically just understands zeros and ones. It has a very small set of instructions like add, multiply, delete, and some logical instructions. On top of it, various languages are designed, and while dealing with the computer, you need to communicate in the same way as the computer understands. And to solve a problem, you must also understand your own knowledge base. If you don't have the knowledge of a particular subject, it is obvious that you cannot go in detail about that subject. So you should also know where to stop, how much is your own knowledge base. The next step is identifying alternate ways. As said earlier, a given problem never has just one solution. There are alternative ways always. You need to just find out which is the best way amongst these. So while identifying the alternatives, what we should see is each alternative should lead to the solution, of course, and the list should be as complete as possible. Discussions with other people will always help finding out different alternatives. That's why a team is necessary while doing all these things. All alternatives must be as complete as possible and should be acceptable. Now, whenever you have listed down the alternatives, we need to select the best way out of it. This can be done by listing down the pros and cons related to each point. Identify and evaluate the pros and cons of each possible solution. Select the criteria for evaluation, and then you can select the best way out of it. Once the best way is selected from the list of alternatives, we can move ahead and list down the instructions for that particular problem. Now what are instructions? Instructions are nothing but these are numbered steps 1, 2, 3, 4 which needs to be followed. One more thing related to instructions is that all should fall in the same knowledge base as in step 2. This can be very limiting, especially while working with computers. Last step is evaluating the solution. Now you have listed down the instructions, you have designed the solution. Now you need to evaluate the solution whether we are going in the right direction or not. So check the result if it's correct and if it satisfies the need of the persons involved. Secondly, if the result is either incorrect or unsatisfactory, then the problem solver must start the process all over again. That is, these are the 6 steps related to problem solving. Let us take an example which will help us understand these 6 steps of problem solving better. Now suppose you have identified the problem as how do a group of people wish to spend their evening. They have a free time and they wish to spend the evening in some or the other way. Now this is the problem which is already identified for us. Now understanding the problem here, which means what? Suppose you are going to list down the alternatives like playing cards or playing chess. Then you should understand here whether all the people involved in that group will be able to play chess or will be able to know the game which is to be played. Here you need to understand the knowledge base of the whole group. Now identifying the alternative ways to solve the problem. Here the alternative ways can be playing cards, then you can play chess, you can just watch TV, you can go out for a movie, or just go for a drive. So these are the alternative ways. Next step is selecting the best among these. Now you'll have to take each and every alternative way, find its advantages, disadvantages, and select the best way. The first, for example, was playing cards. Suppose we decide to play some specific game of cards. What will be the advantage? Everybody will be involved. But what can be the disadvantage? If somebody is not knowing the game, or anybody can not be interested in that specific game. So that maybe it will be discarded. The second option can be playing chess. What are the advantages of playing chess? Mostly everybody knows how to play chess, but the disadvantage can be at a time only two people will be involved. The whole group will not be involved. So we might discard that option as well. The third option was watching TV. This can be a good option wherein there seems no problem with the option. In this way, you can go to each of the alternatives, find the advantages, disadvantages, and then select the best way. Now suppose we select the best way as watching TV, then what is the next step? Next step is listing out the instructions. Now for watching the TV, what needs the list of instructions will be very less, as in what you'll have to do, you'll have to just switch on the television. There is just one instruction involved there. But with different problems, the list of instructions will be different. Now evaluate the solution. What needs to be evaluated? Did you have fun in the evening? Did you enjoy the evening? That is how evaluation of the solution can be done. This was a small example of how these 6 steps will help us in problem solving. These are the 6 steps involved in everyday activity problem solving. For technical problems, there are different set of instructions, different steps involved. We'll see that later. Now, there are two types of problems. Problems can be of algorithmic type or they can be of the heuristic type. As the name suggests, algorithmic type of problems means what? The problems which can have a series of steps 1, 2, 3, 4, and you can solve those problems in such way. Computers are designed to solve the algorithmic problems. The second type of problems are heuristic problems, wherein there is no straightforward solution to it. You need to go on a trial and error basis, round and round about the problem. Now, in algorithmic problems, as we said, it is a straightforward with a series of steps. Examples can be balancing a checkbook or baking a cake, which has 1, 2, 3, 4 standard steps there. Second type of problem is the heuristic problem, wherein it is not very straightforward, needs reasoning built on a knowledge and experience, and it's a process of trial and error. Examples can be buying the best stock, whether to expand a company or not. And as said, it cannot be reached directly by a series of steps. Computers are designed to solve algorithmic solutions, while people are better with heuristic solutions. Can we use these 6 steps to solve both the type of the problem? Yes, we can use both these 6 steps to solve both the problems. However, in step 6, the correctness of the heuristic solution cannot be certain, it cannot be checked. For example, if you have written an algorithm, then obviously if you get the answer, then evaluation is done right. But for heuristic solutions, there is no evaluation as such. So the 6th step will differ. Also with heuristic solutions, the solver will have to go through the 6 steps more than once. As I said, the heuristic problems are like they are designed on a trial and error basis. So you might need to go through all the steps more than once. This does not happen with algorithmic solutions. Most of the problems require a combination of the 2 kinds of solutions. Let us see now how the computer solve the problems. So problem solving with computers. As I said, computer deal with heuristic solutions which are often difficult or very time consuming for humans to solve. It's not that whatever the computer is solving, the humans cannot solve. What is the problem? The problem is it is difficult and it will take a lot of time for a person to solve a particular problem which the computer can just solve in seconds. And people are of course more better at heuristic solutions because computer cannot think in multiple ways at the same time. It can go just one by one in a series of steps. For example, solving a complicated calculus problem is easy for the computer, but how to learn English is not. So the problem is in now Is the problem with the computer? No, the problem is in programming. The programming thing is designed in such a way that computer cannot help. It can just go through steps one by one and it can solve a problem. Artificial intelligence is the field with that deals with heuristic solutions. Now what is done in AI? In AI we try to develop a knowledge base on top of a problem of its own, and the language is designed for there are basically tools for AI which try and find the solutions from those knowledge base which is constructed. Huge databases are there from where points will be extracted and solution is tried and provided. Robotics uses the artificial intelligence technology. Now let us see what are the difficulties with problem solving. There are a couple of difficulties. Just to list down a few are: sometimes people are not being taught how to solve problems. Some are afraid to take a decision of the fear of it might go wrong. Then sometimes the fifth step of listing down the instructions, it might be inadequate. Problem definition itself might go wrong. So the what to be done itself goes wrong. That's why how much ever money you spend on how to do it, it's of no use because you are solving the wrong problem. Next is choosing the alternatives may go wrong. Now so you come down till listing down the alternatives. You have listed down all the alternatives, pros and cons of all the alternatives listed, but choosing which one it might go wrong. So that is one problem with problem solving. Sometimes you might reach the right solution, but whether we have reached the right solution or not, that question might go wrong. Evaluation of the solution might go wrong. The solution might be right, but the person who is evaluating, who is checking whether you have got the right solution or not, itself can go wrong. Incorrect evaluation of the solution.